Well, class, I guess this is the last one for the term. I mean, it's finals week now, so there's nothing else after this. Well, I guess there's summer school, but last for you guys, I hope. I saw this article, and it was came on Tuesday, and I thought it was fascinating. I even think about this. I mean, when I hear lithium, I always think of lithium-ion batteries. The first thing that came up, but I mean, now sodium is an alkali just like lithium, and it's going to have very similar properties, and it makes sense that many of the same things. And the advantages that we have with lithium ions are sodium ions. Sodium ions are slightly larger and they're slightly more dense. They're going to be a little heavier. And because of that, also, because they're larger, not as small as lithium ions, you get a little less energy in them. But if you look at some of these things, I mean, first of all, the price. Because I mean, what are our sources of sodium? It's salt, sodium chloride, and we have lots of sodium chloride. We have an ocean full of salt water. We have salt mines, like in Michigan. We have tons and tons, well, even more than tons of salt just sitting in the ground that we mine on a very regular basis. But if you look at this, there is some little advantage with lithium ion. You can get more energy per volume. Of course, if you want energy per volume, the highest thing is going to be the fissile materials. Uranium and plutonium are going to have the highest. And if you even higher than that is fuel, like gasoline or diesel fuel or petroleum, those are much higher than batteries. But the nice thing about batteries, of course, is the energy is extremely usable that comes out of it very quickly, and almost all the energy, electrical energy, converts to work very effectively. So it's hard to say. Batteries in terms of energy is extremely efficient storing energy. Of course, batteries take a lot to make. And what's nice is safety. You look at the lithium ions. Batteries, these can overheat and catch fire, and a lot of it has to do with the inside of the battery. So if you remember from the chapter, the lithium-ion batteries, they go back and forth between carbon and a metal oxide substrate, and as they move from one to the other, that's when the electromotive force is engaged along the wire. And so sodium does not seem to have this same issue that lithium does as it's and with the lithium ions, if they start making them thinner with the cells and like putting less components in the cells, that's where you had issues like with the Samsung phones, for instance. That was the issue with the batteries. There was just they were skimping in terms of the interstitials, not just the, and put as many lithium ions in cells as they could to make the batteries last longer. And like I said, sometimes they caught fire. So kind of scary. But yeah, this is an interesting read. I like this one, and wanted to end you with kind of a really interesting, where things are going, article. And but of course, as I always say, if you find yourself having any issues, I know everything is due coming up tomorrow, and I really can't extend due dates any further. But if there are any issues, let me know, and I always do what I can to help you as soon as possible. So I'm gonna sign off then. Aloha, and let me know in the future if you need anything.